Hey everyone, welcome to my channel. So today we'll be discussing two sum problem from LeetCode. So what do we have here in this problem is uh, given an array of integers, num, and that integer target. Okay, we want to find out return the indices of two numbers such that they add up to the target. Okay, so we want to find out two numbers which whose sum is equals to the target. Okay, you may assume that each input would have exactly one solution. Okay, and which means is that, let's say, if in this example 2 7 11 and 15, and we are looking for a two element whose sum is equal to 9. So there are only two elements whose sum will be exactly equal to 9, which means there cannot be duplicates. You may not use the same element twice, and you can return result in any order. Okay, so let's talk about this inputs a bit. Okay, so we have 2 uh, 2 7 11 and 15, right? And what we are looking for is 9. So any two numbers whose sum equals to 9. So from here we can clearly see indices 0 1 2 3. The first two numbers adds up to the 9, and that will be the result. So 0 1 is the result. Same goes with the 3 2 4, and what we're looking for is 6. So any two numbers whose sum equals to 6 is something which you're looking for. So from here we can see 2 plus 4 equals to 6, and their indices are 1 and 2, and we'll return 1 and 2 from here. uh 3 3 and 6, so both the numbers are are at different places. So here we also have this clause that we cannot reuse the same element twice, but these are not, but because they are at different indices. So 0 and 1, and I will return 6. So that's the problem. So let's talk about how do we solve this. Let's talk about brute force approach first, because that's the expected that you if you directly reach out to optimal solution, that might not give you a good impression. So always talk about the brute force approach. So what I mean by brute force is, so what is the worst possible solution you can think of? Okay, so for example, here we are looking for, there was an input, right? Two, sorry, yeah, 2 7 9 and 11, and where we were looking for a number 9, right? So here, what is the worst possible solution you can think of? So in that case, you might end up comparing each element with every other element. So here we are looking for two numbers, right? So the first number, you will fix the first number and you will try to find out the second number. And if you can find the such number whose sum, both the elements sums up to 9, then that's your solution. So but in worst case, you, for example, you might end up comparing each element with every other element. So let's take an example. So first you fixed 2, and then second element you will pick 7, and you will compare them whether that's equal to the target number or not. In this example it is, but assuming it's not. So you will compare this with second element, you will compare with 2 plus 9, you will compare with 2 plus 11. So you fix the first number and you compared with every other element on the right side. Okay, same thing you will do with the 7, 7 9 and 11. So you will compare 7 with 9, 7 with 11, and you will try to find out your answer. And same thing you will do with 9, you will compare with 11, and 11, since there is no other element, you can skip that. So that's a n square solution which we have, where you might need to compare each element on the right hand side. Okay, compare with. So let's take an example how we can do that. So generally, if you want to compare each element and with every other element, you can just use two nested for loops. So here, if you can see, we are implementing to some method. Okay, we are implementing to some method, and we are received an integer array and a target, right? So on the first for loop, you are using an I pointer, and it's going till the end of the end of the array. Okay. Second for loop, you will start with the I plus 1. Okay, so you are taking j pointer and starts with I plus 1, so that we fix 2. Okay, so here we fix 2, and then you will fix one of the element on the so here if we see the comparison, nums j equals to target minus nums of I. It's nothing but it's just saying that nums of I plus nums of j it's equal to the target. You can write in any order, that should be fine. But if once this condition is evaluated true, means you got your answer, means you found two numbers, which is nums of, at one number is nums of I, number is nums of j, and which sums up to equal to target, and then you can just return I and j. So this is a brute force approach. You can talk about it in the beginning of your interview. So what is the space and time complexity? So since you are using two for loops, at least you will comparing each element with every other element. So n square for the time complexity, and space complexity is of 1 because there is no extra storage we are using. So let's move on. Okay, so can we improve that? Okay, so we have to n square solution with us, and what we want to find out, can we reduce this? Okay, and since we were doing n square comparisons, we want to reduce n square comparisons using some uh, uh, maybe faster lookup. Okay, so how we can do that? Maybe we can store the result and use that to our advantage. Okay, so here we can take an example. So if we upfront know, okay, let's take an example, 1 3 7 11 and 5. Okay, and we want 14, okay, as a target. So if we upfront know whether do we have target minus nums of I in our array, then if we upfront know whether this element present, in that case we don't really need to scan through each and every element on the right hand side, right? So how we can do that? We can use a hash map. In the hash map, what you can do is you can store the number and their respective indices. So the respective indices are these. So you will store 1 with indices 0, you will store 3 with indices 1, you will store 7 with indices 2, same goes with 11 and 5. Okay, now this hash map already stores the number and their indexes. Okay, now with this just one for loop, we can check, we will go with from I to 0 to length of nums of length, and we can check whether map contains the complement is target minus nums of I. So we already have one number, we are looking for the second number, which is target minus nums of I. So so we are looking for second number, which is target minus nums of I. So the map contains that number. So let's take an example, number is 11, so and target was 14. So if 14 minus 11 equals to 3, if we have this 3, if we have this 3 in our map, means we have our solution. So here we already know the indices of 11 and we already know the indices of 3 because from the map, then we can return that. Okay, look at how the code works. Okay, so so we built a map where we will store the number and their indices. Okay, so in the one pass we stored all these numbers which we have here, right? Okay, so in the second case, in the second for loop, what we are doing is we are just checking whether the complement number is present in the map or not. So, and this we will do for each and every element for the array, and if there is a complement number present, that's an answer. Okay, and since from the input itself we know that there will be one answer existing for this. Okay, so that's an our solution. But this null condition will not come because inputs are organized in this fashion. So if you see, we are not doing for nested for loops anymore. So that's where we reduce the complexity using a hash map. Okay, So we reduce the complexity. We traverse the list containing n elements exactly twice. Okay, since the hash table reduces the lookup time from of n to of 1, that's where we reduce the complexity to of n. Okay, space complexity, yes, space complexity increased from of 1 to of n because now we are storing each element and their indices. So we using with the space trade-offs, we reduced our time complexity basically. Let's talk about, can we optimize this solution again? Okay, so here in one pass we were doing two passes, one pass to store all the results and second pass to check whether do we have complement element present in the hash map or not. But here we can do, I think we can do one more optimization. So let's take an example, 1 3 7 11 5. 1 3 7 11 and 5, and what we are looking for is 14, right? So let's store while building the hash map itself, can we find out the complement element? Okay, let's take an example. So we have this one, and this is our hash map. Okay, this is our map, and same thing we'll do whatever we did in the last solution. So we'll try to find out the complement element. The current element is 1. We will find out complement element, which will be 13. 14 minus 1 will be 13. Do we have 13 in the map? We don't. So we'll do nothing. We'll just store the 1 and its indices. Okay, so same thing, the second, we will go to second element now, and we'll try to see 14 minus 3, which will be 11. Do we have 11 in the map? No. We will ignore it and we'll just store the indices of 3. Okay, let's move on to 7. 7, do we have 14 minus 7, 7 present in indices, but we also need to compare that their indices are not the same because we cannot reuse the exact same element twice. So 7 is not present, so we'll do 7, and 14 minus 7 we don't find in the hash map because it was not there, and we added it now. Okay, that is true. So same we'll do for 11. 11 minus 4, 14 minus 11 is 3. Do we have 3? Yes, we do have 3. So that's where we found our solution. So we'll return indices of 11 and the indices of 3, which we will get from the hash map. So that's why while building the hash map itself, we can reduce our one pass we were doing it in the previous solution. So yeah, let's take a code. Let's take a look at the code. So same thing, we built a hash map, and then uh, from here we just use one for loop. In the for loop we are looking for the complement element in the hash map. If it is present, then that's our solution. For example, for when we came across 11, 14 minus 11 was 3, so we got two elements. Okay, with sum equal to the target element. So that's where we will return map minus get complement. And in case if it is not there, we'll just put the element into the hash map and return. So what so in this case we just improved the time complexity a bit. Instead it's still of n, but instead of doing two passes, we will be getting an answer in one pass itself. And this is our space complexity. Yeah, same complexity is same because we might end up storing all the elements. Yeah, that's about it. Thank you everyone. Just let me know your feedbacks and comments into the comment section, and so thank you.